Okay, good afternoon, everybody. Um, our last class, we were talking about the crime scene itself. And you'll remember that the boundaries of a crime scene are set to include the area where all physical evidence may be present. And we need to actually talk a little bit about what we mean by physical evidence, because there are some quite strict definitions for it, quite strict meanings. Before we proceed, though, I want to remind you that removing anything from a crime scene, no matter how important it looks, has to be done in accordance with the strictures of the Fourth Amendment, which accords us the privileges that we are not subject to unreasonable search and seizure. And just go back, please, to the last couple of slides of our last class and read over those again to remind yourself about the importance of the Fourth Amendment and those circumstances, those narrow circumstances under which the Fourth Amendment privileges are lifted, where an investigator can, in fact, remove evidence in absence of an actual warrant to do so. So the reason that I emphasize this is because I'll just point you to these two cases. This is very frequent that, in fact, a case is ruined because the investigators have not followed the Fourth Amendment requirements. So, for example, in this case, Mincy versus Arizona, it was actually a case involving the death of a police officer at a crime scene. The responding officers and investigators to the scene of the homicide were able to take physical evidence immediately, but they carried on searching that property for a number of days. It was a 4-day search. It was just continuous, and they removed very important evidence subsequent to the initial response to the scene. And the defense claimed that the evidence had been seized illegally. There was no warrant. The court found that the initial response to the scene did not require a warrant, but that subsequent apprehension of physical evidence from the scene did require a warrant, and no warrant was obtained. And none of that evidence could be admitted in court. So the court found that the circumstances did not justify ignoring the Fourth Amendment requirements, and the case was not lost, but it was rendered extremely difficult because so much evidence could not be admitted. In this other case, Michigan versus Tyler, this was a fire, an arson, which was an insurance fraud scheme, and evidence was seized at the time of the fire. Now, you'll remember that that you can do that. You don't need a warrant to do that because evidence is in imminent danger of being destroyed. So that was legal. But they carried on for a long time searching and taking away physical evidence and acquiring physical evidence from the scene for nearly 3 weeks, more than 3 weeks. And this was done without a warrant. And the court found that the initial seizure under danger of loss because of the fire was legal, but none of the subsequent evidence could be admitted in court. This is how important it is that responding officers and investigators understand exactly what the requirements of the Fourth Amendment are. And it's a very, very powerful protection against harassment and against illegal search and seizure, unreasonable search and seizure. So physical evidence encompasses any and all objects, things, which can establish a crime has been committed or provide a link between a crime and then between the victims and the perpetrators, and actually contribute to the story which we construct about how the crime was committed. Physical evidence, for example, does not encompass eyewitness testimony, is not physical evidence, nor is a written confession, nor are the notes that a investigator makes. The physical evidence is physical stuff, which is maybe tied to the crime. It doesn't have to be, even under a warrant, it doesn't have proven that did. It can be taken as physical evidence, and the likelihood that it provides information. There are a couple of things to say about this. This means there's a tremendous responsibility on investigators to actually recognize what relevant physical evidence is present at a crime scene. That is maybe a huge danger in itself. The investigator may simply not recognize that something is participant in the crime. This is one of the advantages of having trained evidence technicians come in and examine the crime scene closely, because they are trained to look for particular characteristics of physical evidence. The second thing is, I taught extensively in the last class about how evidence has to be handled, how evidence needs to be removed from a crime scene, how especially it must be packaged so that it doesn't become damaged or contaminated or anything like that. Second of all, how a chain of custody must be clearly established and maintained throughout the history of that piece of physical evidence, from its discovery at the crime scene, to its removal, to its deposition at a laboratory or in an evidence locker, et cetera, to its analysis, and then ultimately, if it's admitted as an exhibit in court, or if a report is produced, that piece of physical evidence, it can be traced all the way from the final conclusions to its origin. And we know exactly who dealt with it and when, so that it never left the chain of custody when it could have been tampered with or altered. The range of things which can be physical evidence are, of course, enormous, absolutely enormous. And it's very, very difficult for an investigator to know how significant a piece of physical evidence will be, because that is in fact something which is decided by the jury. It is the jury in their deliberation who consider all of the admitted evidence and decide what had particular relevance, what is particularly informative to them in making their decision. What is admitted in court is the responsibility of the judge. So what is admissible, that's the responsibility of the judge. But the jury, once it has been admitted and has been declared in court, exhibited in court in one way or another, it is up to the jury to decide what its importance is. So there's an incredibly long list of things that could constitute physical evidence. I'm just going to mention some of the ones that we are going to be talking about. We will very definitely talk about body fluids, because these are important in various ways. We're going to talk, for example, about the importance of blood spatter, and blood patterns, that sort of thing. But of course, these all now have a particular relevance because they may be used to extract DNA and a DNA profile. Documents in possession of either the victim or perpetrator or at the scene may be very important. Presence of drugs, explosives, all of these things. These fibers are carefully examined for in many circumstances, although we will hear that there are limitations to the use of fibers. Fingerprints, of course, you know about. Firearms, ammunition, their importance should be self-evident. But there are also all sorts of other things that we may think about: hair, glass, tool impressions. If a window has been forced, something like this, that mark that the tool leaves is actually physical evidence. Paint chips have proved to be extremely important in automobile investigations, especially hit and runs. And arson, petroleum products and vapors, even though it may be difficult to think of a gas as being a physical evidence, it very definitely is, because it can be trapped, it can be removed from the scene, and can be identified and analyzed. All of these things, plastic bags, polymers, all sorts of residues, anything which may have been brought in from the outside, for example, sand, wood, leaves, all of these things could be physical evidence, and it is up to an investigator to recognize that they may be important. That may result in the investigating officers collecting far more than turns out to be necessary. But that is far preferable, although it makes identification and analysis lengthy and may make it difficult. Nonetheless, it means that the likelihood is that they have included everything of importance. Far better that than leaving a crime scene, opening it, and realizing afterwards that things were left behind and then destroyed or compromised and cannot be used as evidence. So the identification and also the level of relevance of physical evidence may be decisions which are made after the collection. So a piece of physical evidence will go to a relevant expert at whatever level for identification, and all the information that it can offer will be extracted by that expert and then presented in the form of a report. And then a decision can be made of how important is this in the overall story? How does it link up with other pieces of evidence in telling the story? The experts who look at a piece of evidence look with specific aims. And usually the very first aim is to identify what they are looking at. Decide, what is this? And at what level of identity can we place, at what level of identity can we place on it? What I mean by that is, for example, an investigator may see stains at a crime scene. It is not up to the investigator to decide what that stain is. They will sample that stain and send it to somebody for identification. Is this blood? If it is blood, then the identification analysis will proceed further. But the first step is to decide what it is. We have a stain. Is it blood? Yes, it is blood. Then whose blood is it? That is an entirely different question. In other words, we identify the piece of physical evidence and then we compare it. We link it usually to something or someone in order to derive its full information. As I've said to you before, a fingerprint on its own is a piece of physical evidence, but it is useless unless it is tied to someone. The same with a blood stain, etc., etc. So the comparison analyses usually compare the questioned or suspect specimen, the unknown fingerprint, to a standard specimen, a known fingerprint, for example, taken from a suspect or from people in the household so that they can be eliminated. So that those fingerprints can be eliminated as in importance. The examinations, whatever they are attempting to establish a common origin for the substance or the object. It depends upon what the expert is looking at, but the examination may be extremely complex. I'll give you an example. Just establishing, for example, that a stain is blood is relatively easy to do. Establishing a profile, a DNA profile for that blood stain is a lengthy and very complex process, but it is now a very well established process. So it is not necessary. It is necessary that that be done by an expert who has expertise, proven expertise and documented expertise in that field. But it's not necessary for that expert to come and testify in the court unless the court calls them. They can submit a report to the investigating office, and the investigating officers can then submit all of that information to a district attorney or whatever, and it is gets put into the whole story for the prosecutor to present in the court. But it is very important that we be able to identify who it was that made the analysis and how they arrived at that analysis. Okay, because that may be the subject of challenge. The defense may well challenge that, and then an expert must be brought into court to explain exactly how the tests are done and what the level of certainty of those tests is. We carry on using our examples. The blood drop. First of all, is it blood? Second of all, much more complex, whose blood? Is that powder residue on a piece of clothing? What is that black powder residue? Is that from a firearm? If it is, we need an expert to be able to tell us, yes, that's firearm. That's from a firearm. And the expert may then be able to proceed with analysis and actually tie that powder residue to a particular set of bullets of the black powder in a set of bullets in the possession of somebody. The analysis must proceed as far as it can to tie the suspect stain or whatever to a likely point of origin. So the same thing, for example, a looser example would be if they observe fibers on the jacket of a suspect at a place distant from a crime scene, say, and they collect those fibers. Those fibers on their own have no evidentiary value, but they can be compared to fibers from a crime scene to see if there is similarity between them. We've said this before, but all of these tests need to be accepted as valid by the court, and they need to be explainable in the court so that both the judge and the jury understand exactly how the tests were done, and especially the level of certainty that can be associated with them. And as we've said before, in general, a judge hearing a new technique may accept it into evidence, provided certain strictures are met. Provided, for example, it has been subject to peer review, that other experts have looked at the technique and said, yes, this is acceptable, especially if it has been published. That gives it enormous relevance. And in addition, the court has to hear this in an initial presentation from somebody with real expertise, not just from some Joe Blow coming in and saying what they think about this technique. It has to be initially presented. If it's a new technique, it has to be presented by the expert who developed the technique. Once they're established, once a technique of analysis of physical evidence is well established, then you don't need to hear all the original stuff anymore. Once a court of law, in fact, usually once a court accepts a technique, usually after that it is very easily accepted by subsequent courts. It may still come under challenge. It may come under challenge at any time. But once courts have begun to accept the technique in general, it is much easier to have it accepted by other courts, so it can be repeatedly used. So this issue of comparing the sample versus a standard is a very important one to understand and to know about. It's actually been the downfall of many a piece of evidence in court, that the methods of comparison were imperfect, and it could not actually, and a piece of evidence collected at a scene could not, in fact, be firmly tied to an origin, no matter how hard the prosecution tried to say that it was. But it's usually this two-step process. An expert may not just be looking at one particular characteristic. They may be looking at several characteristics of what they are looking at. And they are chosen carefully, and the sample is subjected to tests and experiment to determine these characteristics. The standard reference sample, let's say something taken from a sample taken from a suspect, has to be analyzed in exactly the same way. You can't draw comparisons if you don't do exactly the same technique of analysis. The expert who does that must be prepared under oath to reach a conclusion which they are able to report to investigating officers. And that report may be entered into evidence, but the expert must always be ready to be called as a witness, and may well be called as a witness. And a prosecutor, in case of very important pieces of evidence, a prosecutor very often chooses to call the expert in rather than have somebody report on it secondhand, because this gives it enormous weight. And in fact, the courts far prefer that. So let's say there is a question stain. An investigating officer sees a stain. There's a rape case. They see a stain on the sheet. It is likely to be semen. The investigating officer cannot himself or herself establish there and then that it is semen, or is unlikely to. There are some tests that you could do to do so, but they will be more likely to collect the sheet or whatever as evidence, or parts of the sheet as evidence, and send them off to the laboratory for examination. And they will then test them. They will test first to establish whether or not it is semen. There are certain chemical tests you can perform, but there are also microscopic tests which are performed in the laboratory to look for sperm cells themselves. That investigation cannot be a destructive investigation, because the analysis is far from complete. The DNA still needs to be extracted from that stain, and it needs to be characterized. Now, that DNA, the semen from the semen stain, is worthless on its own. It needs to be put into comparison, into a comparative structure. So there are two ways in which this is principally done. First of all, if you have a suspect, the suspect can be asked to or required to provide a DNA sample. That is very easily done. It's done with a cotton swab, which is swirled around in the mouth on the cheek cells. That extracts abundant DNA, and that DNA that sample is treated in exactly the same way as the semen sample was treated. And then the expert ends up with an analysis, a DNA profile for each, for suspect and for standard. And they submit that to the investigating officer. And very importantly, in the case of DNA, the investigator will be able to provide the authorities with a statistical comparison. They will be able to say the chances, okay, let's say the samples are identical, right? The suspect and the standard are from the same person, and are identical rather. They can then say there is a 1 in 23 billion chance that somebody on the planet has the same DNA. They're not saying, the expert doesn't say this is from the same person. The expert says these two samples are identical, and the chances of that happening by chance with somebody totally unrelated is 1 in 23 billion or whatever it is. That's really important, because there are many pieces of physical evidence, as we'll hear, where such statistical probabilities of error cannot be established. That is one of the reasons DNA is such a powerful piece of evidence. So at trial, whoever it is that has been elected to present this evidence, the forensic officer, let's call them the person presenting the physical evidence, etc., will testify, first of all, to the seizure of the question item, in this case, the stain. They will testify that it was the circumstances under which it was seized were immediate at response to a crime scene or under warrant, etc. They will establish the Fourth Amendment validity of the seizure. They will then establish the entire chain of custody, or at least make it available to the court, so that the defense can examine it especially. They will then describe the process of the examination and identification as reported by the expert. And they will then present the expert's findings. The prosecution may well elect, maybe in case of DNA or something like that, to have an expert come and explain to the jury how the analysis is done or was done, and what the relevance of the statistical bounds are, because that's not necessarily clear to the jury. The jury are ordinary people. They maybe have no scientific training, and the testimony of an expert witness can elucidate the physical evidence importance to a great degree. Okay, so in talking about evidence, we realize immediately that really there are two kinds of physical evidence. And the first, we've spent most of our time talking about so far: fingerprints, blood, these sorts of things. This is physical evidence which is said to have individual characteristic. That is, it can be tied to a single common source, if you're lucky enough to find that common source. Now, in the case of DNA and of fingerprints, I said there are two ways in which we often try to establish the source. And the first is, both fingerprints and DNA, is by sampling, getting as a standard samples from a suspect and sometimes from associated people, other people in a household, for example, or but from suspects, etc. And we compare between them. So that is the one way. The other very important way, which we have now of doing that comparison, is by putting it into a database. There are databases being maintained of fingerprints derived from many different sources, but especially from other crimes. There is also a very large database now of DNA profiles, which we can take our question sample and compare to, in the hopes that somebody has previously been profiled, and we will get a match that way. this now happens with increasing frequency. This all depends upon the physical evidence having individual characteristics. That is, it can be tied to a single common source. Fingerprints, DNA, bullets and casings, bullet casings, which we'll hear later. We'll hear how they become individualized. These all have individual characteristics which are unique. They are unique to their source. So that if we have a sample derived from that source, we can link them back up together again. However, it's not always possible to provide the kind of statistical backing that DNA analysis has. So, for example, we may be able to match a bullet and the gun that it was fired through, but it is very difficult to establish what the statistical probability of that being correct is. So that we have to make various assumptions about. Nonetheless, we regard it as being true individual characteristic. And it's usually the probability of association is so enormous that the likelihood of it being just by chance is absolutely minimal or beyond our ability to comprehend. So the chances, for example, that the markings on a bullet match the imperfections in the barrel of a gun, the chances that that bullet also matches another gun uninvolved with the crime is extremely, extremely remote. We can just know that by common sense. We don't have to do a mathematical computation to realize that the chances are infinitesimally small. So let's have a look. Here's a real case. I'm going to point out to you that the opposite of individual characteristic is called class characteristic. And a class characteristic is one which can be attached to a group rather than to an individual. It may still be very useful, but the piece of evidence gives us information. It can be identified to a larger group, not to one single individual. So here, but be careful. Here's a case. In this case, it was a stabbing, and this little piece of metal here was recovered from a bone in the stab victim. This very frequently happens. The weapon breaks off bits during the stabbing when it hits the hard bone or whatever. So this was recovered from the victim. This blade here was recovered from a suspect, in the possession of a suspect. It's actually an X-Acto knife. Now, forget about this blade being found with the suspect. Just think about what it was, the importance of this little piece of metal when it was all on its own, recovered at autopsy. Well, the first thing is this little piece of metal on its own has class characteristic because it's very easily established that this comes from an X-Acto knife blade. There are characteristics of X-Acto knife manufacture which would tell us that this is a bit of an X-Acto knife. So, well, that may be important because for the start, it tells investigators, keep your eyes open for an X-Acto knife. You may see an X-Acto knife associated with the crime scene or whatever. You may see an X-Acto knife associated with a suspect. Look in their toolbox. Look in their drawers. See if you can find an X-Acto knife. That is exactly what they did in this case. So they recovered an X-Acto knife and its blade from a suspect, and it had a chip. It had a piece out of the end. On its own, this little piece of metal constitutes class characteristic. It tells us to look carefully at X-Acto knife blades or look for X-Acto knife blades. But it doesn't tell us directly which to look for until we put them together. Because this now moves from being class evidence to being individual evidence. And why? Because this break here matches perfectly. Every little imperfection in this break matches the imperfections in the break on the blade, on this part of the blade. That's point number one. The chance of that occurring in another instance is infinitesimal, by chance in another instance, infinitesimally small. You can break 1 billion X-Acto knife blades and never, ever end up with exactly the same break marks. That's the first thing. The second thing is to look very carefully at the knife, at the blade. Look at these striations here. Those striations there, and then these striations here. These striations are produced when the hot metal is rolled and to produce the thin blade. They produce a thin sheet of metal by rolling a very hot ball of metal. And these are imperfections in the metal, in the hot molten metal, which are acquired at random. These marks here are marks, these striations are produced in the sharpening process. That thing of metal then goes through a sharpener, which puts the edge on it. And they are also produced at random. They're random imperfections in the sharpening wheels, which continually change. The wheel is continually getting worn down and damaged. So new kinds of striations are produced. So they are also produced at random. But when we put this little bit of metal, which only gave us class information, together with this suspect blade, we get, first of all, that match there, and then we get a perfect match of these striations here. And this moves this little piece of blade from being class to being very strongly individual evidence. So the same kind of principle can often apply. For example, here is a case where a body was bound in polyethylene bag, in a trash bag. I think she was dumped in a river. And this is the bag that was used. They developed a suspect, and they, under warrant, examined his premises and discovered a roll, a big industrial-sized roll of these black plastic bags. And they took that roll into evidence, and they tore off some. And lo and behold, the top bag, the first bag that they tore off, when they put it together with the suspect bag here, not only did the tear marks here, you can't really see, but the tear marks matched there. And these striations in the bag also matched. And again, these striations are produced at random in the manufacturing process. Molten plastic is poured out and then is rolled very thin to produce the polyethylene film that makes the bag. Is then folded. It is sealed by heat, and the little dimpled thing where you tear it off is produced. All of those produce individual characteristics. On its own, this bag gives us class evidence. It tells us that somehow other black plastic bags, which are unbelievably common, were somehow involved. It tells the investigators, keep an eye open for sure, but had they never found the matching bag, which gave individual character, this would have remained simply as class evidence. The perpetrator, whoever they were, used a black plastic bag. But when comparison was made to physical evidence seized from a scene, seized from the premises of a suspect, it acquires individual characteristic. So class evidence is not to be discounted. Class evidence is it can only be the identity can only be associated with a group. And so many important things like blood groups, for example, very extensively fiber evidence, and even hair structure, as I'll explain in a while. These all only give us class evidence. Okay, so blood groups, you recover blood from a scene, and it is group A, right? That means you're pretty sure, for example, that blood came from a suspect, right? That was a blood trail leading away from a stabbing scene where the suspect presumably cut themselves. You tested it's group A. That tells us to keep an eye out for people who are in group A, but it does not tell us that anybody that we suspect with the A group is guilty. It tells us that the suspect belongs to group A, and that it may be important for one reason. It narrows our area of concern. It narrows the field for us. Very importantly, it can exclude people. You may have a suspect who is group O. Well, that person could not have produced that blood trail, so they would be excluded. Class evidence often has that characteristic. But in terms of dealing with a particular suspect, our suspect who has group A, we have recovered group A blood. All we can say about it is the possibility that this blood trail was produced by suspect X cannot be excluded. We may have another suspect with group B. We would say the suspect is excluded on the basis of this class evidence. Sometimes it becomes contentious. So here is one which has been the subject of considerable controversy. And this is hair evidence. Now, this pertains to hair structure evidence, not to DNA recovered from hair, which may be done, as I'll discuss later. So here is a side-by-side comparison. Again, we've got a suspect. We've got a questioned hair, rather, recovered from a victim or a victim's clothing, maybe, or from a crime scene. And here is a standard. This is taken from the suspect. And they are compared under a comparison microscope. And you can see that they look very much as if they were identical. So your initial instinct is to say, aha, this is individual characteristic. Unfortunately, it's not, because we could, in fact, collect many similar hairs from many different people. And in addition, hair structure varies in an individual. You can collect hairs with different structures from the same individual. So all that this does, in actual fact, is it allows us to say the suspect cannot be excluded. This is controversial because for quite a long time, this would have been presented in court as being individual evidence, not class evidence. And it required a considerable number of defense challenges to all of the techniques to reveal that, in fact, there was, if you presented this, there is a considerable likelihood that this hair on this side came from an entirely different source to this side here. They do belong to the same group, we can say that, but we cannot say that this is identical. This is the person that provided this hair was the source of this hair. We can only say that this person who provided this hair belongs to a group which includes the person who donated that hair. So that is this very, very critical distinction to learn that we have to make. And the error has been made many times that class evidence has been presented as if it was individual evidence and has been challenged and struck down in court. In many areas of forensic science, there is an inherent weakness in the scientific basis of the work, because we are unable to assign exact or even approximate probabilities of error to what we conclude. And the ability to assign a probability of error is the hallmark of a proper scientific investigation. So, for example, here is another one which also became extremely controversial, especially towards the end of the 20th century. We recover a nylon fiber, let's say, from a suspect's clothing. It looks anomalous on their clothing, and it is collected. And it is then compared to fabrics and fibers from a crime scene. What is the statistical probability that similarity is because the fiber originated at the crime scene? We can't say. And unfortunately, especially in fiber evidence, millions of these fibers, millions of these fabrics are produced. They are very widely distributed, and a suspect could in fact have picked up an individual fiber from many different sources. What you can say is the fiber is consistent with fabrics recovered at the crime scene. That's about as much as you can do. There was a time when fiber evidence was given great weight. It is no longer given that weight for the simple reason that you cannot say with any certainty what the probability is that it definitely came from an individual source. Same thing often applies. A paint chip, for example, or a piece of glass, or what, we can look at the chemical composition, we can look at the color composition, et cetera, but we need to realize that many of these things are produced in bulk. They are not produced as individual objects, they are produced in bulk. And so it may tell us the group that this object came from, but it does not necessarily tell us the individual object that it came from. This is increasing difficulty because we live in a world where everything is mass produced, and essentially, things emerge pretty much identical from the factory. So it's very difficult when we look at a piece of that to say, well, this came from this particular individual, except under special circumstances. And that, for example, I've already discussed, the knife blade, the sheet of polyethylene, where we could match individual characteristics, but that often is not possible. We can only assign class characteristics. The great importance of class evidence is twofold, really. The first is it narrows the field of search. The second is that if we accumulate lots of pieces of class evidence and they all match, they all seem to lead back to a common origin. We not only recover fibers from a suspect's clothing, we also recover paint chips which match at the crime scene. We also recover soil from the garden at a crime scene, et cetera, et cetera. Each on their own may not have particular weight, but as we start to add them all together, at least in narrative form, not in mathematical form, but in narrative form, they begin to acquire particular weight. But the real importance of class evidence is that it very often excludes people. It excludes suspects, and it saves us from having to pursue investigation of those suspects or that line of inquiry any further. So there are ways sometimes in which these class characteristics may in fact have some statistical probability attached to them. And when that is the case, when we look at them together, if we have their mathematical probabilities, we can actually provide a summation by multiplying the probabilities. This is, never mind about all of the math, just accept it in this particular example will make it clear. This is from the O.J. Simpson case, which, if you want to read about it, is a classic case of physical evidence being completely mishandled and a crime scene being utterly and absolutely mishandled, if not destroyed, by investigators. It's it was a catastrophic event in law enforcement and in forensics. And it showed up how, in fact, how easy it is to completely botch an investigation. But there are bits of evidence which still emerge from it. So there was blood found at the O.J. Simpson crime scene, which was an extremely violent stabbing of 2 victims. A huge amount of blood, but there was some blood which appeared to have been dropped on the suspect's way out, and it was tested. First of all, that blood was it had the A marker, the A antigen, the A glycoprotein. The proper word is glycoprotein, but it had the A antigen on it. So it was group A blood. Well, O.J. Simpson was also group A blood. But 26% of the population, more than a quarter of the population, are group A. All it tells you is that the perpetrator was likely from group A blood. Then there are some other markers. There are other blood factors that you can look at. There are all sorts of other things. But here are 2 of them. They also looked at this one, which is called ESD, but 85% of the population, it was on the suspect blood trail, it was present, and it's present in 85% of the population. Doesn't help you much. It's a class characteristic of many, many people. They also looked at this one, PGM. Only 2% of the population have that. So it's still class characteristic. It's 2 out of 100 people. That's quite a lot of people. You can't say, anything about O.J. Simpson on that basis. However, what we're going to ask, this is the likelihood. 26 out of 100 people have A blood. 85 out of 100 people have ESD on there as a blood marker. 2 out of 100 have PGM as a blood marker. What proportion of the population have all 3? Have A blood, which also bears ESD and PGM? It's a mathematical question. It's not a question of biology or whatever. It's a mathematical question. And all that you do is you multiply the probabilities. And I'll just point out that it's formulated here, 26, that is 26%. That's 26 over 100 is 0.26. 85 over 100 is 0.85. 2 over 100 is 0.02. If we multiply these together, we end up with 0.44. 0.44. And that means less than 2 out of 100 of the population. Less than 2 out of 100 of the population end up carrying this. This is a mistake, by the way. This should be 0.044. I'm sorry, I didn't do this. But less than 2 out of 100 of the population carry all of this. This begins to make it look very much like O.J. Simpson is high, should be high on the list of suspects, right? Not on the basis of individual, of each of these, which are class characteristics, but by multiplying the class characteristics together. Now, just imagine something. Given that less than 2 out of 100 people have all 3 in combination, just imagine you add into that there's some other little pieces of class information. Let's say that O.J. Simpson had blue carpet fibers in his house where he had no source of blue fibers, but there was blue carpet fibers source at the scene of the crime. Could you calculate a real probability of his involvement? No, you couldn't. There's no statistical probability attached to fiber work, right? You can't say anything about the statistics of that. But in narrative form, putting those together, we would be able to make a very strong argumentative, a strong forensic case, remembering that forensics is an argumentative procedure. We would be able to make a strong argument that in fact he had been involved. So what should become obvious, an individual piece of class evidence, like our chip of X-Acto knife blade, that can cross over. It can cross over as it acquires individual character. And for example, one of the most best examples is that of a fingerprint. Just looking at fingerprints, we classed fingerprints basically into 4 different initial groups. The initial look at a fingerprint puts it into class evidence. But an expert looking at a fingerprint looks for very, very small characteristics on the fingerprint, which vary from person to person. And it's up to the expert to decide how many of those small differences added together end up producing an identification of a fingerprint as being truly individual. And we're going to hear later on something very, very interesting about that procedure, because up till now it's been accepted that 20 to 30 of those little minor differences between fingerprints was enough to make a fingerprint individual. It turns out that that's not enough. There was in fact one case where there has transpired one case where 2 people were identified as having the same fingerprint. They didn't have the same fingerprint. They just had very, very similar fingerprints with 20 similarities between them. But when they looked further, when they counted 30, 50, 100 differences, they were able to say, no, those were different. So this is just an example. We need to be very careful. We need to define our terms very, very carefully and not make assumptions about what constitutes individual and what constitutes class. How many striations on that knife blade are necessary to move it up from class to individual? These are difficult, very difficult questions to answer, and they may well be the basis of legal challenge in court. So, as I've said, as in the O.J. Simpson case, these are even class evidence with class characteristic is still tremendously important, because we can start to put things together. And the likelihood that class evidence could exonerate someone is as important as the fact that putting many pieces of class evidence together may point to a suspect. So I said that we're lucky nowadays because much of this information can in fact be computerized. We can put it into computer databases, and you need to hear about a few of these databases that are available. For example, this one is the oldest of these databases, and it's called the Integrated Automated Fingerprint Identification System, or IAFIS. Now, many states maintain their own databases. They put into those, it depends on the state, so what they can put in. Some states you are allowed to put in, for instance, fingerprints taken at the DMV for one reason or another, or fingerprints taken by the IRS. Certainly fingerprints taken at arrest, fingerprints taken in prison, etc., etc. All of these are sources of fingerprints, but it does vary from state to state. If you consent to have your fingerprints taken and included, that's fine. But just taking fingerprints in itself needs to conform to the Fourth Amendment, because it can be construed as unreasonable search and seizure to force somebody to give their fingerprints even when they're not suspect of a crime, for example. Nonetheless, many states maintain extensive databases from whatever source they can get their fingerprints, and IAFIS does as well. IAFIS is the FBI database, an enormous, enormous database. In the old days of fingerprinting, what had to happen was that somebody had to sit down and by eye compare the question fingerprint with standards over and over and over and over and over. There were ways of narrowing the field as well here, but still it was a lengthy, very, 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 very tedious process, and could take a very long time. It could take months to go through and try and match. And you might never, very often might not make a match, even if it turned out that the fingerprint match was there. But the forensic databases depend upon a computerized artificial intelligence analysis of differences, similarities of question fingerprint with fingerprints that they have on record. And it is done extremely quickly. At the time that these slides were prepared, it was 80 million standard entries, probably far more than that now. And there are moves now to establish international fingerprint bases. You can certainly send fingerprints to other countries for analysis, but there are moves to make international databases available to law enforcement. So here's a question print, and here's a print which was on file, taken under ideal circumstances probably. But these databases may also include fingerprints recovered from crime scenes, which can be very useful because it can tell you that the same perpetrator committed more than one crime, even if you're not initially able to identify the person. Especially state databases will sometimes include questioned prints in analysis, so that those linkages can be made. So that is IAFIS, and AFIS are the state-based ones. This one, the Combined DNA Index System, CODIS, is a relatively new database, but one that is growing exponentially. The source of these DNA samples is sometimes a matter of controversy. If you agree to give a DNA sample, then it becomes available to law enforcement. If you agree to give a DNA sample to law enforcement, it becomes available throughout law enforcement and can be entered into the database. Some states require people who have been arrested to give a DNA sample. Other states do not. Other states only require felony convictions to donate DNA, et cetera, et cetera. So there's a mishmash of requirements, but nonetheless, this is an enormous database of DNA profiles. And again, a profile derived from a crime scene can be, where there's no suspect, can be entered into the CODIS system. And if there are matches, usually I should add, in all of these cases, the machine does not tell you. What the machine does, it usually produces about 10 matches or so. And the final match has to be done by a human being. It cannot be done by the machine. The machine can only tell you, here are your likely matches. It cannot give you a single match and say, it will give you that match plus a range. And the final must be done by an expert looking at it. DNA sampling has been deemed by the Supreme Court to be part of normal police procedure, like fingerprinting and photography. But that has come, and that may be true, but it has come under state challenge, and it's not necessarily the case. Depending on state that you're in, and depending on the level of police involvement, as to whether they can automatically demand a DNA sample. So there are numerous other of these databases. There is one for ballistics called the Ballistics Information Network, or NIBIN. And this contains a huge amount of information about bullets, guns, about bullet markings. And it's kind of like a fingerprinting system for guns. There is even a National Forensic Automated Paint Data Query database. This is actually in Canada, and has proved extremely useful in hit and run cases, and as I'll show you in a second. And there's even a database for shoe prints. Shoe prints are very common at crime scenes. They can be left in as an imprint, like if somebody steps in blood and then leaves a footprint. They can be left in dust. People come in from outside with shoes with soil on them and leave shoe prints, and it can be extremely useful. Of course, it is at just identifying the shoe make and model and everything, that is class evidence. But you will hear later on that shoe prints can be raised to the level of individual evidence as well. But this would at least give you the class evidence of which manufacturer, which batch, years of production, places it was sold, the shoes were sold, etc. And it has proved to be extremely useful. Here, for example, here is a questioned shoe print, and that's on the right-hand side. And it's being compared. This is not a match, obviously, and it's being compared to everything in the database. There are 22,000 of shoe prints on record. So here are some real cases to finish off with. This gives you the value of establishing databases, as opposed to having a precinct or districts have to try and examine all the evidence just that they have in their historical record. Gerald, this person was beaten to death in his home, and in 1975, and they found a very good fingerprint which was lifted at the scene. And 16 years later, somebody put that into the AFIS and IAFIS systems and identified somebody. It came up. That person was not actually involved in the murder, but had witnessed the murder and had never come forward. But when they were confronted, they came forward and identified the killer 16 years later. This was a famous rape case, the Center City rapist. There was a series of serial rapists in Philadelphia, and associated with it was a murder. And then it ended in Philadelphia, but a series of rapes began in Colorado, and they actually managed, from one of these cases, to get a DNA sample. And they were able to link both through DNA, they were able to link the rapes in Philadelphia with the rapes in Colorado, and they were able simultaneously to show that it was an army person, an army man, and his DNA was linked to the Philadelphia attacks. This was all done through CODIS, through submitting to a database. Without CODIS, they would not have made the link between the Philadelphia cases, the Colorado cases, and the happily married army man. It was through submitting it to a database where his DNA was present, I believe, because he had been in some special forces or something in the army. This case here, I said that I'd refer back to the paint database. This was a hit and run accident. in California. And this man was hit and killed in the roadway. It was hit and run, and there were no witnesses. And but the impact left paint chips on his clothing, and there was a little tiny piece of gold painted plastic, which they believed had come from the vehicle that had caused the accident. And one of these paint chips had the complete paint history, essentially. It had the primer and the base coat and the top coat and everything on it. And from that, they submitted it to the database, and they identified it as coming from a Ford vehicle. And they were able to give an approximate date of 1990 or later that they had used this paint combination. So that is class evidence. And they then went through all of the possible vehicles that had used this paint combination, and they identified a particular gold color, which was only used on 1997 Mustangs. Well, there are 11,000 of these Mustangs had been made. That's not very many. And they decided to start off just looking in the area of jurisdiction of this defense, and they discovered 2 of them. And they went to those addresses and examined them, and one of them had damage to it, had paint chipped off it, but most importantly, it had a piece of the molding at the side, which was gold. The plastic molding had been broken off, and the paint was consistent, matched, but much more important than that, the pieces fit together with individual characteristics. So it was undoubtedly all of this physical evidence collected at the scene was tied to this particular vehicle, and hence to one particular perpetrator. Okay, so now this was a little bit shorter than yesterday's, but I want you please to watch this movie, The House That Roared. And I want you, while you're watching it, don't just let the images go. Sit and list the forensic evidence, list all the physical evidence that was collected and used. Make a careful note, especially of how the blood evidence is evaluated, because this is important. All right, and then don't forget you have your first test tomorrow. It is available from 8 o'clock tomorrow until after 11 on Sunday. An hour and a quarter. As soon as you start, you get an hour and a quarter. There are 50 multiple choice questions, and it is closed book. It is not an open book exam. Please do not cheat. All right, I will see you then on Monday.